There are also parallel scans, and these apply to both tables and indexes, implying multiple CPU platforms executing reads from tables, indexes, or both in parallel. There are different types of joins, which are very important to remember, which the optimizer will use. These are namely nested loops, hash joins, and sort merge. A nested loop is most efficient for a very small dataset joined with a large dataset, in other words, one row joined to 1,000,000 rows or one row to 1,000. A hash join will be chosen by the optimizer as the more efficient option than a nested loop when the rows between the two tables are more or less the same. In other words, 100 rows joined with 110 rows, or 1,000,000 rows joined with 1.1 million rows. A nested loop is always the fastest option. Bear in mind that if you join two tables and pull one row from each, the optimizer is going to select a nested loop. The optimizer will always select a nested loop as the best option because it is the most efficient. Effectively, the nested loop really requires a small amount of data in the first table and a sorted amount of data in the second table, which is generally either the same or much larger in row count than the first table. A hash join requires that at least one table is actually accessed in a sorted order, in other words from an index, and the second table can be accessed in any manner. What happens with the hash join is that it creates a temporary hash table in memory in order to execute the join. A nested loop doesn't have to create that temporary table, so it's by nature faster than a hash join, unless of course the hash join applies where you have large numbers of rows in both tables in the join. A sort merge join is the most inefficient type of join because it executes a sort on both row sets. Generally, a sort merge join is selected as the worst option of the three when both row sets are not sorted. In other words, you're accessing two tables, joining them together, and the way in which you're accessing both tables is not sorted at all. In other words, you're not including keys or any indexes in either of the tables joined together, and particularly in the join. Sort merge is the least efficient, nested loop is the most efficient, and obviously when executing a SQL code statement you can override the different types of joins selected with something such as a hint, and obviously with the ways in which the parameters are structured. For instance, you can remove the use of hash joins altogether by setting hash area size to 0 or setting various other hash join parameters. A semi-join is a special type of join used with subqueries, typically with the exists and in operators, where it kind of joins but it doesn't quite join because you don't necessarily retrieve columns from the subquery, unless of course you're using an inline view, which I mentioned in a previous movie. So that's the basics by which the optimizer selects data from the database. It uses a table scan, an index scan, a parallel scan, or a join. And within those different object scans there are specialized types of scan. The most efficient way to access a large table is by using a row ID obtained from an index. A small table is most often efficiently accessed using a full table scan. The best way to access a single row from the database is using an index unique scan and plugging that into a table scan to find a single row with a row ID. If you're retrieving an entire dataset, then you either use a full index scan or a fast full scan. Skip scans can miss prefix columns. Reverse scans simply access an index in reverse string order. An index range scan is used to access ranges of rows, in other words more than a single row or something that says greater than, less than, between, etc. Parallel scans can execute on multiple CPU platforms, which can be efficient. Quite often this kind of thing is best accessed using Oracle partitioning. Joins occur in 4 different ways: nested loop, hash join, sort merge, and a specialized type of join called a semi-join. The nested loop is the most efficient and a sort merge is the least efficient.